Video 1 of our Chapter 4, we will be discussing different types of sampling designs and how we can sample from our population. So two bad sampling designs that we've already referred to that you guys read about. Number one was a voluntary response where you just let people decide if they want to be a part of your sample or not, which can introduce an unknown amount of bias into your sample. And number two, a convenience sample is whenever you just kind of choose whoever you want to be in there. Again, this will introduce a lot of bias to your sample. Now, the way to avoid all this extra bias is to allow what we're going to call impersonal chance to choose a sample for us, because a sample selected by chance does not allow favoritism or self-selection and reduces a bias by giving all individuals an equal chance to be chosen. So we are going to want to introduce some sort of randomness, random sample to this whole concept. We don't want to come up with it, and we don't want people to come up with their own sample for us by volunteering, but we want people to be kind of just randomly chosen. Now, the most common random sampling technique is called a simple random sample, and it is abbreviated in SRS. The AP test, for me, for instance, any of your teachers would recognize an SRS as a simple random sample, so you may use that abbreviation. A simple random sample is chosen so that every group of individuals has an equal chance of being selected. It's not that every individual has the same chance of being selected, but it's that every sample within your population has the same chance of being selected. So if this is our population here, and here's our sample, if we were wanting to randomly select 3 people, well then here would be our 3 randomly selected people. Now, this sample of size 3, if I can get a different color here, this sample of size 3 has the same probability of being selected as any other sample size or sample of size 3. What people start to confuse themselves with is, if you think about it, if this person was chosen first, then they had a 1 out of however many people are in the population. Okay, a 1 out of n chance. So if this person has been selected out and we don't replace them, then the second person has a 1 out of, well, now there's 1 fewer in the population, so he has a 1 in n minus 1 chance of being selected. So the probability that these 2 individuals are selected is not the same probability. The probability starts to increase as we decrease our population of being selected. So that is the main reason why we say that it must be the whole sample. We don't care who got picked first, second, or third here, but this whole sample has the same chance of being selected as, say, this random sample of 3 if they were randomly selected. All right, 3 ways you can take a simple random sample. We can use an actual physical model, like, say, drawing names out of a hat. Now, what we'd want to ensure is that every person's name on a piece of paper is on equal sized pieces of paper, and if you're going to fold them, you fold them all the same way so that each piece of paper would really look and feel like every other piece of paper. All right, so this is a very physical routine here, drawing names out of a hat. We could also use a random number table. These are typically in the back of your book. I have one in the back of your formula sheet for you. And there's just a long string of digits between 0 and 9. Now, the thing to know is the random number table truly isn't random. It's based on an algorithm, which means it's called pseudo-random, but it's random enough for our purposes, okay? Now, each number in the random number table, the 0 through 9, are equally likely to happen. So it doesn't matter if we get 2 zeros in a row, a third 0 is still equally as likely to occur as a 9 would be coming up next. Each number is independent of all the others, which means, again, if I had 5 zeros pop up, just because I have 5 zeros pop up doesn't mean that a 6th one could pop up next. It still has the same chance. Some things to note about the random number table here. Do I got that on the next page? I do. So let's just look at this. You'll notice the random number table has a column listed for line numbers, and this just makes it easier to pick a certain spot on the random number table. So we don't always have to start at the very beginning. because if you always start at the very beginning of a random number table, it's not truly random then. Now, you'll notice that there are groups of 5 numbers at a time. And why are there groups of 5? It just makes it easier to split up the numbers instead of just having one super long string of digits here. So it's just really ease for why the numbers are listed the way they are in the random number table. Now, a third way is to use technology, aka your calculator, Excel, just your computer in general, the internet, whatever you want. But we're going to discuss specifically your calculator. So there's a random integer function in your calculator. So if you go to your calculator and go to the math button, which is right below the alpha key, you want to scroll over to where it says either PROB or PRB for probability. And then we want to go down to number 5 for randint. This is going to randomly select integers for us. And integers mean no fractions, no decimals in here. So let's select that. Now, one of two things will happen. If you have a newer calculator, like this one is illustrating, it will give you a menu. But if you have an older calculator and your calculator just says randint parenthesis, you're going to need to know the order of the parameters that will do the randint function for you. The lower just means what's the smallest number you want selected. So let's just say we want, the smallest number we want is 1 up to, let's say we just have a class of 30. All right, so we have 30 students. We're going to number them 1 to 30. And then the n represents how many random numbers do you want between 1 and 30. Let's say I want 3 students. So if you don't have this menu, again, you're going to see randint parenthesis. You're going to want to put in the lower value first, comma, the upper value second, comma, how many numbers do you want selected at a time? Now, if you don't put in a number where this 3 is at, by default, your calculator will just give you one number. So you don't have to put a comma 1 here. You could just end it after the upper value, and your calculator understands. All right, so now let's see what that looks like. Doop, doop, doop. There we go. And so here are my 3 random numbers, 29, 28, and 5. Now, if I want 3 more random numbers, I just got to press enter again, and it'll just redo it. So 16, 13, 23. And I could just keep going all day long, and I'm going to keep going until something very specific happens. Oh, there it is. Notice in this instance, I had a 9 get repeated. That will happen with the randint function. Okay, so just beware, it doesn't give you 3 unique numbers. The random integer function randomly selects integers with replacement. Okay, that means it puts the number that it selects back into the pool of, in this case, 30 numbers, and then pulls out another one. So if you want to avoid getting repeats, then what we should really consider doing, let's go back to the randint function, would be instead of doing 3 numbers at a time, let's just do 1 number at a time. And then if I need 3 numbers, then I just press enter 3 times, and I'll take 13, 10, and 30. And if I get a repeat, let's see how long it takes before we get a repeat in here. Kind of back to back. Oh, there was a 30 from before. So if you got a repeat, you would just skip it, press enter again to get your next value. All right. Why might the AP test and the Chapter 4 test require you to use a random number table as opposed to the randint function? Because it would just be so much easier to use the calculator here. But if I need to make sure you are truly understanding what's going on here and that you know how to randomly select numbers, I don't really know if you figured out how to do it on your calculator or if you just made up like 3 random numbers, off the top of your head, which really isn't random because your mind's kind of pointing you to which numbers to pick, right? So just to make sure everybody's on the same page, the AP test will pretty much make you use a random number table, or they'll give you a line in a random number table so that everybody gets the same answer, just so we know you really understand the material. Now, besides a simple random sample, there's some more complex types of samples. So number 4, we've got a stratified random sample. A stratified is where we have a population and we can split up that population into strata, or really groups that are very similar to each other. We're making our groups really homogeneous, if you will. So here's a nice cloud that's made up of 3 different types of groups of people, we'll say. And we can pull those similar people, those homogeneous groups, into their own strata. And then what we can do is from within each strata here, within each little subcloud, we can take an SRS, we can take a simple random sample of each strata. Now, why might we consider doing a stratified random sample? Is if we want equal representation from each group of, individuals in this case. Because a simple random sample could come along, and let's say here's our population. If I said I want to take a simple random sample of size 3, let's say. Well, if I took a simple random sample of size 3, it could be that I get all 3 of these green squares. And those 3 green squares might have a different opinion than maybe the red circles or the blue triangles. But I'll never know because I just happen to randomly pick those 3 green squares. So to guarantee equal representation of different groups of people that maybe have different opinions on something, you might consider doing a stratified random sample. Another example I have down here is if I wanted to split up the freshmen, sophomores, juniors, and seniors. Maybe I want to discuss, or maybe I want to survey what types of foods to serve in the cafeteria. If I take a simple random sample, worst case scenario, I could get all seniors to be in my sample. And since seniors aren't going to be eating food in the cafeteria next year, they could just say, we want Brussels sprouts and slugs for all we care. And, if everybody says Brussels sprouts and slugs, the cafeteria people are going to go, hey, this is what the people want. They want Brussels sprouts and slugs, so let's give it to them. Then all the freshmen, sophomores, and juniors next year, they're going to be pretty PO'd because they didn't get a say into what kind of food that would get served in the cafeteria. So to make sure there's equal representation, we could stratify on grade level and then simple randomly select from each grade level. Number 5, a cluster sample. Now a cluster sample looks it'll feel really similar here to a stratified, but there's a big difference. In a cluster sample, the population's already broken down into preformed clusters naturally. One way to think about this would be different classrooms in a school. This could be talking about city blocks in a city. We could be talking about counties in a state. We could be talking about states in a country. But anything that's already kind of preformed. Each cluster is perceived to be similar to other clusters, not exactly the same, so there's kind of a heterogeneous mixture already within each cluster. We're going to randomly select however many clusters we need for our sample, and everyone in that cluster will be a part of our sample. Okay, so in my picture here, let's say this cluster of people got selected. I don't just randomly select some of them to be a part of my sample. I take all of them to be a part of my sample. That's the big difference between a cluster and a stratified random sample. Stratified, again, we only select some from each strata, but in a cluster, once we pick a cluster, we take everyone in that cluster, not just some of them. Number 6, a systematic random sample. The systematic part means we have a system for how we are going to randomly select our individuals or whatever we're selecting here. So individuals are selected according to a random starting point and a fixed periodic interval. So for instance, if I had a street that had many houses on it, instead of deciding and randomly picking which houses I want, if I came up with some sort of random starting point, let's say I randomly select the second house to be my starting point, and then I just need every, let's say, third house on the street. So I randomly picked this house, but then my system says my fixed periodic interval is to skip the next 2 houses and hit the third, skip the next 2 houses and hit the third, skip the next 2 houses and get the third. What a systematic random sample does is it really kind of spreads out your random sample so that you're kind of hitting from all over the place. Okay? The fixed periodic interval, the every third house in this example, isn't a random thing. And how do you get, say, the every third house? Well, let's look at this example here, and you'll see where that number can come from. Out of 100 students, I want to randomly select 5. Student 42 is randomly selected as my starting point. Then a fixed periodic interval is determined. Typically, you're going to take your population size divided by your sample size. So I wanted 5 students out of 100, so I'm going to select every 20th student. So in this example up here, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 houses, and apparently I needed what, 4? 4 in my sample. So 11, and we'll just go with 12 since it's a little bit nicer. 12 divided by 4 gives me 3, and there's my every third house. So if you need to round a number to get the every however many for your fixed periodic interval, that's absolutely fine. Now, if you reach the end of the list, like let's say, this is, if I started here and I want to go every third house, then I'd skip this one, then go back to the very beginning of the list, and then I'd select this house, and then skip the next two, select this one, skip these two, select this one, and I would be done at that point. All right, the last one we'll refer to is called a multi-stage random sample. This is really, I mean, its name implies what it is. It's a very multi-stage, multiple things going on here. And there's a variety of different things that can be considered a multi-stage. So I'm going to talk about a couple specific ones here. This example I have over here says, imagine we have a cluster sample, and then individuals are randomly selected out of each cluster instead of just taking the whole cluster of individuals as your sample. So we could do a cluster sample, and then we could treat those clusters that we select like they're stratas. And then we can randomly select from each cluster. So it's kind of like we're doing a cluster sample with a stratified random sample, and then that could be our overall sample. So really when you combine really multiple techniques here, this is a multi-stage random sample. The other example over here is we have counties across the whole US, and we select those counties, and within each county we want to select certain areas of that county. And then within each of those areas we can select houses from there. So there's kind of a one sampling technique going on here, and then there's another one going on. So again, that's where the multi part comes into play. Now the last one I want you guys to take a look at. It says the manager of a sports arena wants to learn more about the financial status of people who are attending an NBA basketball game. Keyword there, financial status. He would like to give a survey to a representative sample of the more than 20,000 fans in attendance. Ticket prices for the game vary a great deal. Seats near the court cost over $100 each, while seats in the top rows are $25 each. The arena is divided into 30 numbered sections from 101 to 130, and each section has rows of seats labeled from A near the court all the way up to double Z at the top row. Would a stratified random sample using lettered rows or a cluster sample using the numbered sections be the best option to guarantee a representative sample of the various financial statuses of people attending the game? And my hint to you is consider the worst case scenario of each to decide which is superior. One of those two sampling techniques could end up being that you maybe get all richer people, people that sit closer to the court, or you could end up with people who are all in the nosebleeds and their financial status is going to be a lot lesser than others. So just think about if you were to randomly select either stratified rows or clustered numbered sections, which one would you be guaranteed to hit a person from each sample or from each financial status? Now, that is all for video 1, and we will see you at video 2.